Good afternoon. We are looking at operation research, and of course, the topic we are looking at is linear programming. Okay, so in operation research, we have only 6 topics. The first one has to do with linear programming, which is the LP. Then we have the transportation. So we have transportation problems. Then, of course, we have the other topic here, which is assignment. So we have the assignment problems. Then we have networking. Then we have queuing. So we have the queuing. And the other one is on decision theory. Okay, which is on decision theory. So the question what we're going to look at now would be on linear programming. Okay, so we have the question here. This question is talking about okay, so it says the LGK electronic company. Okay, so LGK electronic company is engaged in the production of 2 components. The C1, which is component 1, and the C2 that are used in the plasma television sets. Then each unit of C1 costs 10 kwacha in wages and 10 kwacha in material. So the wages is 10, the material is also 10, while each unit of C2 costs 50 kwacha in wages and 15 kwacha in material. The company sells both products on 1 period credit terms, but the company labor and material expenses must be paid in cash. Okay, so the company labor and the expenses must be paid in cash. The selling price of 1 unit of C1 is 60 kwacha, and then the selling price for C2 is 140 kwacha per unit. Now, because of the company's strong monopoly in these components, it is assumed that the company can sell at the prevailing prices as many units as it produces. The company production capacity is, however, limited by 2 considerations. Okay, then there is first, at the beginning of the period, the company has initial balance of the 8,000 cash plus bank credit plus collection from the past credit sales. Then second, the company has in each period 4,000 hours of machine time and 2,800 hours of assembly time. the production of each. Okay, so the production of each of our C1 requires 6 hours of machine time and 4 hours of assembly time. Then whereas the production of each C requires 4 hours of machine time and 6 hours of assembly time. We need to formulate this problem as a linear programming so as to maximize the total profit to the company. This is number one. Then number two, we need to solve the linear programming problem that we formulated in one using the graphical method, and then interpret the results. So what is important here is to make sure that we use the variables so we can let the product. Of course, this company is getting production of 2 components, C1 and C2. So the C1 can be represented by X1. Under the graphical method, as we solve this one, when you are using the graphical method, the presentation of the graph should always have the X1, the X1 and X2. So we have the X1 and X2. Now, there is one thing we need to do here is to actually make sure that we say, let the C1 be represented by, because from here, what is happening is that, okay, so what is happening here is that we have, okay, we have this information here. We are simply saying, let the C1 be represented by X1 and the C2 be represented by X2. So in a starting point, we have the wages and material for these products. So from the question, we are simply we have been told that the AGK electronic company is engaged in the production of 2 components, C1 and C2, that are used in plasma television sets. So the C1, their wages and material cost, which is 10 kwacha for wages and 10 kwacha for the material. Okay, for these two, for the C1. And then the other one here for C2, the material, the wages is 50 kwacha, and then the material is 15 kwacha. Okay, and then the company sells both products on 1 period credit terms, but the company, okay, but the company's labor and material expenses must be paid in, okay, in cash. All right, so must be paid in cash. Okay, so the selling, so here we have the selling price of CC1 is 60 kwacha per unit, and and then the other one for C2 is 140 kwacha per unit. So because of the company's strong monopoly in these components, it is assumed. So from here, we're able to get the information from here, the material cost, and of course, the wages cost. So what is going to happen here is that we can say wages. Okay, so the wages for C1 is 10. The material for the C1, and this one is representing by X1. This one, let it represent X2. All right, so now what is going to happen here is that we are going to say our wages is 10 kwacha, the material is 10. For the C2, the wages is 50, the material is 15. So meaning that we can formulate our profit. So the profit on C1 is equal to selling price, which is 60, minus these costs. Okay, so the selling price was 60 there. So meaning that our profit is equal to, we know profit is equal to selling price minus cost. So profit, we are simply saying sales minus cost. So it's S selling price minus the cost price. So this is on how we are finding our profit. Now, getting down to this one, we are simply saying the profit on C2 is also 75. All right, so this is on how we are getting to the cost. Okay. So from here, what is going to happen is that the profit on C1 is 40 and profit on C2 is 75. So this is how we are going to maximize the objective function. Okay. So we're going to maximize our objective function. Okay. So our objective function will actually be given by, okay, so this one will actually be given by maximize Z is equal to 40x1 plus 75x2. So this is on our objective function. So we're combining. So the total profit made on C1 is 40 multiplied by the number of units. So this is the total profit on C1. Okay, and this is the total profit on C2. So C2 total profit is actually 40x1, and then the profit on our C2 is 75. 75 by how many units we are producing on X2. So X2 is representing C2. And then our C1 total profit will be 40x1. So this is how we are getting the objective function this way. Now, from the question, we are also been told that we have, okay, the information to do with they're simply saying that, okay, we have here where it says we have the total number of hours for the machine and then assembly. I'm saying the company has in each period 4,000 hours of machine time and 2,800 hours of assembly time. The production of each C requires 6 hours of machine time and 4 hours of assembly time, whereas the production of C2 requires 4 hours of machine time and 6 hours of assembly time. So this can be presented this way. Okay, so the total number of hours we have here. The C1, this is this product C1, machine hours is 6 hours of machine. And the assembly time is 4 hours for this product. So it's 4 hours of the machine time for C1. Okay, so we have for C1, we are simply saying it has how many hours? C1 requires 6 hours of machine time and 4 hours of assembly time. All right, and then the C2 has 4 hours of machine time and 6 hours of assembly time. So this is about what we're having here. Okay, so this is what is going on here. The total number of hours that we need for C1, okay, we have 6 hours of machine time, 4 hours of assembly. But we know the total number of machine is 4,000 for both products. So this is why we have this table here. Okay. So in this one, we have for this table here, we have the 6 hours for C1, 6 hours of machine time and assembly is 4 hours. For C2, 4 hours of machine time and 6 of assembly. So the total machine is we have 4,000 hours. For the assembly time is 2,800. These are the number of hours that we have. All right. So meaning this constraint, we have this other constraint here, meaning we're combining. So this XC1 is represented by X1. Then the C2 is being presented by X2. Okay. So now the constraint that we are going to have here will be 6 multiplied by X1, which will be 6X1, plus 4 multiplied by X2, which will be 4X2, which should be less or equal to 4,000. Okay. Yes. So we are having this review. Please, if you are behind, find time to join us. Find time to join. All right. So there is just a minor addition to the solutions that has been done. Okay. So here we are just doing a review on this linear programming. Okay. So all right. So I'm sure people are following. Okay. So the question we are looking at is this one here. Okay. For this campaign. So we are just looking at how many hours in total were there for machine for these products. And then how many hours were there for assembly. Okay, so there were assembly time hours and there were machine time hours. Okay. The tutor, I'm the tutor for this one. I'm sure somebody was asking. All right, so now we have this kind of equation. So we're trying to make sure that we solve this problem. Okay, so we are formulating the linear programming. The most important thing here to note is this: the material cost the material cost and wages for product C1. So let C1 be X1. All right. And then the other one, the C2, the cost was 15 wages and actually 15 in material. So we are just doing the solution for this. Okay. And then they're saying the company sells both products on one period credit terms, but the company labor and material expenses must be paid in cash. Okay, so must be paid in cash. So the company labor and material must be paid in cash. So the selling prices are those. So meaning we had to find the net sales for those ones. Okay, so the net sales, meaning that the objective value function actually was given by this one. We are saying profit on C1, we are actually trying to, okay, we're just trying to make sure that we formulate the linear programming. It will almost where's the child? Is it different or what? People are now leaving. Yeah. All right. So we are now continuing. So what is going on here is that we are supposed to formulate the will not be an issue. Okay. So solving will not be an issue after formulating the. So the total profit that is there for this one, we have formulated the objective function. Okay, so the objective value function has been formulated. So we need now to solve. Okay. Um, Okay, so we can continue now. So meaning that here we have the objective value function, which is given by 40x1 plus 75x2, which is this one we have gotten. And then here, what is happening is that we have our x1 and our x2. So the x1 for the machine, for the C1, it requires 6 machine hours and 4 assembly from the question. Then for C2 product, C2 requires 4 machine hours and 6 assembly. And the total machine hours was we had 4,000. And then assembly supposed to be 2,800. That these were given. So this constraint, meaning that 6x1 plus 4x2 should be less or equal to 4,000. Then the 4x1 plus 6x2 from here should be less or equal to 2,800. Okay, I'm sure people are with me. So this information is being obtained from this one here, where we have the question here for AGK Electronic Company. The information for relating to the formulation of the AOP is actually from this one here. Now, the other point we need to, the other constraint that we need to introduce here is this one here, where they are saying the company sells products on 1 period credit terms, okay, but the company labor and material expenses must be paid in cash. So they must be paid in cash, all right? So now we have this one. First, the beginning of the period, the company has initial balance of 8,000 cash plus bank credit plus collection from the past credit sales. So they are simply saying that the company sells products on 1 period credit terms, but the company labor and material expenses must be paid in cash. All right. So this is what I am saying. And then they're simply saying, first at the beginning of the period, the company has initial balance of 8,000, okay, which is cash plus bank credit plus collection from the past credit sales. All right. So meaning that we have the one we have here is the formulating. So we are going to have the solution here when you're going to solve these ones, okay? Now, there's this solution here that has been prepared. So what goes on here is that we need to graph these constraints. This constraint here came from here for the labor hours, okay? And then we would have another constraint here. So that solution, we are supposed to revise it. So I'm supposed to go for the other constraint. The other constraint here is that we have this information here. The information from the question is simply telling us that the material cost, okay, each unit of C, the company is 10 in wages, 10% in wages, and 10 in material. While for C2, the cost the company is 50 kwacha in wages and 15 in material. And then the selling prices were 60 for C1 and 140 for C2. Of course, this one, we have explained how we are finding the profit. Okay, so the profit for per unit of this product, your profit per unit will be the selling minus the costs. So meaning that this is why we have the 40 here for that product. And then here we are subtracting to get the profit, which is 140 minus 15 minus 50, which is giving us 75. All right. Okay, so now these are the profit per unit, and this is why we are simply saying our objective function, we are going to maximize this profit, which is 40x1, because the C1 is presented by x1, the C2 is presented by x2. And then the machine hours, this is information is coming from the question for machine hours. So machine hours, we had this information from here for relating to the machines, all right, which is C1, 6 hours machine, 4 hours assembly. And then for the C2, it's 4 hours machine hours and then 6 hours assembly. So this is why we are now getting down to this problem here. And then the total machine hours, these were the total available hours. So even here, these are hours which are available. Okay. So, and then this is x1, so multiplying 6. So the C1, we're simply saying, let C1 represent the total number of hours, okay, for machine, and then the C2 for machine, okay. C2, this one, the C2 is represented by x2. So these are the constraints. Now we have another constraint here where we are simply saying the total for the, okay, so the total for the total, or the total cost for C1, total cost for C1, total cost for C1, C1 total cost is equal to 10 plus 10, which is giving us 20 kwacha. For aggregate, this is the total cost was 10, meaning that the cost of wages and material. So we have the wages and material. Then so this is for, so this one is still represented by x1. Then for C2, which is x2, our total cost is actually going to give us the wages from here is actually 50, then plus the other one is 65 for the material. So it's 15, okay? So this is 15, so the total is giving us 65. All right, so meaning this is the total cost for C2. We are simply saying it is equal to 50 for the wages plus 15 for material, which is giving us 65. So this is the total cost per unit of C2, which is given by X2. So this is another constraint that we need to incorporate here. So for the first one, the table of values, we can say 0,1000. Now, this one, what is going to happen here is that for the constraint 3, the other constraint which we are going to incorporate here will be equal to, okay, we have the 20 x1 plus the 65 x2. should be less or equal to 8,000. The 8,000 was given in the question. So the way the 8,000 is coming from is actually from this one, where it says the company sells both products on one period credit terms, but the company labor and material expense must be paid in cash. So labor and material expense must be paid in cash. All right. So the opening cash that we had at the beginning, okay, at the beginning, the company has initial balance of 1,000 cash plus bank credit. This is where the 8,000 is coming from. So the total what we spent on product 1 and product 2 was supposed to be paid in cash. So this is why we have another constraint that we have incorporated here, which is this one. So this one, we can say, so meaning that the LP problem should be now given by this. Okay, so LP problem should be given by, we maximize our Z, which is equal to, all right, Z, which is equal to, there were 40x1, so 40x1 plus, okay, 75 x2. I will explain again for those who are behind on how we put the objective function. Subject 2, the constraint 1 should be the first one, which is 20 x1, then plus 65 x2, which should be less or equal to 8,000. Okay, which is coming from there. Then the other one is coming from the machines, where we simply say 6x1 then plus 4x2. Okay, so 4x2 should be less or equal to 4,000. All right. Then the other one will be, so the other one we are simply saying 4x1, so 4x1 plus our 6x2, which should be less or equal to 2,800. So this is the LP problem. Okay, then we can say our x1 and x2 should be greater or equal to 0. x1 plus x2 should be greater or equal to 0. This is the LP problem. So I will need to run again through this one. If this problem is wrong, then the answers may also not be correct. The answers will not also be correct. Okay. Oh, no, having a challenge. All right, so this is it about where we are getting this one from. Okay, so what is happening here is that the total cost should be paid in full. Okay, that's what I was simply saying. The total cost, yes, and the company sells both products on one period credit terms, but the company labor and material expenses must be paid in cash. So we are using the cash initial balance of 8,000 to pay for the material. So the total cost of material for product C1 was that of the wages and the material here, which is 20 that was spent there. And then that of the other one, okay, so meaning this one is the one I'm talking about where the cost came from. So the total cost of this one plus this one, the total cost is 20. And then the total cost of product C2 is 65. The wages and material should be paid in full from the amount. Which amount? The amount that we have here is the 10,000. So using the amount here, there's the total amount here. Okay, there's a total amount of so the total amount that we have here is all right. So this is what is going on here. So every information for every information for the formulation of the LP here for the first one, okay, for the 8 marks, we have gotten it from the information from here, okay. So the information from here is where we have gotten the formulation of the linear programming. Then we are going to solve the problem using the graphical method. All right, so meaning that the first thing we need to do is to come up with a table of values for the constraints. So we have from here, we have gotten the constraints. Okay, so the constraints that we have these ones. Of course, the way we got the objective function, we subtracted to get the objective function this way. So this objective function came from this one, all right, where we are finding the profit on product C1 and profit on product C2. Okay, so that is our objective function. And then this one came from the hours that we have for a machine. We had 4,000, and for assembly we have 2,800. Are people following so far? Excuse me, are people following so far?
We are following.
Okay, so the objective function, we subtracted these. I'm sure what is important is to understand the objective function. So meaning selling price minus all these costs, which is a 40 there, 60 minus these costs, and then 140 minus these costs, we got this one. So this is where the objective function came from. Then the other one, okay, then the other one, which is for the labor hours, machine hours, we had 4,000 there. So meaning let C1 represent X1, the C2 represent X2. So meaning we had 6 multiplied by, so this is where these ones came from. All right, the 6x1, 4x2, this is where these ones came from. So this one, we can call it constraint 2. This one also constraint 3. The reason is because from the question here, we had the first one here where they're saying, first, at the beginning of the period 1, the company has initial balance of 8,000 to pay for material and also to pay for, okay, to pay for material and labor expenses, to pay for the labor and to pay for the material. So pay for the wages and material. Okay, so this is why, so that the budget allocation of 8,000 to pay for the labor, okay, and the material. So meaning that from here, we have the total material was 20 for C1. This was my total material cost. Then C2, the total cost was 65. Okay, so this is subject to this one. So from here, we can graph these ones. We can graph those ones and then see. So this is the AOP formulation for the 8 marks. Okay. So for the 8 marks, this is our linear programming formulation. Okay. So this is how the first one, where it says formulate this problem as an AOP, which is linear programming, to maximize the total profit. So that is just the 8 marks for formulation. So the solving is not an issue because you can be solving the wrong AOP. So if the AOP is correct, then you're going to solve the right linear programming problem on using this one. Okay. So we are going to solve that one now. So getting down to the table of values. So using this one, we can now sort out this. So we can use the graph this way. Okay. So let this one be x1. Okay. And then this one be our x2. So here we can put a 0. So we can come up with a table of values. So table of values for the first one, we can simply say we have the 20 x1 plus 65 x2, which is equal to 8,000. Okay, which is equal to 8,000. So meaning we can come up with the table of values here. How will be the table of values? So meaning that here to be our x1 and our x2. So what are we saying here? We're saying if x1 is 0, what will be our x2? So we are substituting there, please. If x1 is 0, x2 will be what? 8,000 divided by 65, which will be 123. Okay, so it will be 123. Okay, 123.08. 0.0 what? 0.8. Now, if x2 is 0, what will be our x1? Our x1 will be 400. I'm sure people are following. Okay. Then let's go to the other constraint. So this is constraint 1. You have those table of values. Constraint 2. Okay, so constraint 2, what we are simply saying is our 6x1 then plus 4x2 is equal to 4,000. All right, is equal to 4,000. So we simply say our x1 and x2. So what are we saying here? We are simply saying if our x1 is 0, our x2 will be 1,000. As we are doing the graphing, if our x2 is 0, our x1 will be equal to 6.7. All right. Please take note of these ones that we are doing. Constraint 3 is 4x1. So we're substituting there. We're just using those points. 4x1 plus, all right, plus 6x2. These ones are obtained from the information given in the question. So it's equal to 2,800. So what we are simply saying here is that our x1 and our x2, So what are we saying? We are simply saying, if our x1 is 0, our x2 is what? Our x2 is actually equal to, all right, so is our x2 is actually equal to what? Is actually equal to 466. 466. All right, 4.7. Then if this one is 0, this one will give us 700. So what we are simply saying here is that these table of values that we have, we can actually now say that from this working that we have here, all right, you need to graph these ones. So when graphing this one, we can use the same old solution which is here. There's just a minor change here. So this one, we are going to graph this one. This graph is okay. This graph is okay. We're using these table values. There was just one constraint that was left out, which is the constraint that was left out here is where we are using this one, where we are using this one, 0,123.08. So 0,123.08 and 400,0. So 0,123.8. So 0, you can graph it this way on the feasible region. So there was another one that was supposed to come. So 0, it was supposed to be like this. So this is the only constraint that was left out to this solution. So this one, I've added it. So we are also going to shade it down. Okay. So here, this is our feasible region where all the shadings from all the lines converge. So 0,120. So you have this one, this point, and this point here. Okay. So the shading for this line should also come here. So this point here is our feasible region. This one is a feasible region. It's a region where all the shadings from all the lines converge, where they come together. All right. So this is our feasible region. Okay. So now, what is this point here? This point is 400, using the corner points. So here we have 400,0. Okay, so this is 400,0 here. So it's 400. Okay, so this is 400,0, and this is 123. Okay, so this is 0, what? 123, 0, 123.08. So 0, 123 point what? 08. This is it on this point. So the corner points of the feasible region, okay, after graphing here, the corner points of the feasible region, we have the following. So under corner points, so under the corner points, okay, we have the first one is equal to 0, 0, then 0, 123.08, and we have also 400, 0. All right. So these are the corner points of this problem. So we are maximizing our objective function, which is equal to z is equal to. So as we go back, we are maximizing the objective function, okay, which is equal to 40x1 plus. So in a nutshell, what I'm trying to explain here is that our objective function is actually from here. We are maximizing this objective function, and this one is obtained from the information given in the question. And these are the constraints that we have. Constraint 1, constraint 2, there were supposed to be 3 constraints in this given problem. Okay. So these are the constraints that we have graphed there. Okay, on this one. So the constraints that we have graphed here. Okay, we have this one. So from here, the feasible region is a region where all the shadings converge. So this triangle down underneath is a feasible what? Feasible region, where all the shadings from all lines converge, where they come together. So meaning that we are going to have, okay, we are maximizing Z is equal to 40 x1, then plus 75 x2. So from here, our Z is equal to, using these corner points, it will be 40 on 0, the first one, again plus 75 on 0, which is giving us 0. Then the other one, we are going to say our Z is equal to 40 on 0 plus 75 on what? 123.08. All right, so 75 by 123.08 is giving us the 9,231. Then here we are getting the other one. Z is equal to 4 on 400. Okay. Then plus 75 on 0. So meaning that this one give us 400 times 4 is 1,600. Okay, so we can now choose the one where we are going to have the maximum possible value. All right, so from here, we are simply saying our objective value function came from this information where we are just sorting out the sales, selling price minus these were cost. Okay.
Hello?
Yes, please. Is that a question?
Is it a 40 or 4?
Oh, it was a 40. Oh, sorry, it was 40. Correct. Thank you very much for that observation. Thank you very much. Yeah, you are following. Thanks very much. So it's supposed to be a 40, yes. Yeah, thank you very much for that observation. Thank you very much. So 40 times 400. So it's 16,000 actually. So now optimal solution is given by this one here. 16,000. Thank you very much for that observation, please. So our optimal solution. So optimal solution is now given by our x1 is equal to 400. Our x2 is equal to 0. And our Z is equal to 16,000. So this is the final answer. So as we maximize this, the final solution should actually give us this one. All right. So this marks the end of this question. Please take note. I emphasize that here there was a minor, we left out one constraint on this one for the initial one. That's why we incorporated it. All right, and that constraint which we actually left out was because of this information was sidelined. We in the initial solution, so that's why we have corrected it. there is this information here where they are simply saying that for the cost of product, this company, AGK Electronic Company, is engaged in the production of two components, C1 and C2, and using the plasma of the television set. So here they're saying that each unit of C1 costs the company 10 kwacha in wages. And the material for the C1, it was a starting product, so you can let it be our X1. Okay, and it has the wages and materials. Then even the C2, the C2 here, it had wages and materials. And then they're saying that the company sells both products on one period credit terms, but the company labor and material expense must be paid in cash. So those ones were supposed to be paid in cash, meaning that at the beginning of the first period, the company has initial balance of 8,000, which is cash plus bank credit. Okay, so they were using the same 8,000 to sort out the material cost. So here, in the terms of material cost, we had the total material cost for these ones. For C1, the total material cost was, it was wages and the material, so it was 20 kwacha. Okay, 20 kwacha per unit for both. Okay, so 20 kwacha per unit for C1, and the C1 was being represented by X1. Then also for the C2, which is X2, the total cost was 65, meaning the addition of these two, the wages that was supposed to be sorted out. So this is the reason why we had now the total cost for C1, wages and material, was 20 kwacha per unit. And for C2, it was 65 kwacha per unit. So that's why we had the constraint. The constraint here, for constraint 1, that's how it was 20 for the C1. And then the other one was for C2, the total cost, which were, these ones were being paid using the 8,000. That's why this is constraint 1. All right, and then getting down to constraint 2 on the second way, they are saying, secondly, okay, for using the other information here, they said, secondly, on the second, the company has in each period 4,000 hours of machine time and 2,800 hours of assembly time. So the production of each C1 requires 6 hours of machine. So this is where we had this kind of information here, where we simply looked at least where the machines and labor, the machine and assembly. So this is for constraint 2, and then this was for constraint 3. All right. And then after getting these constraints from here, because we are simply saying C1 should be represented by X1, C2 should be represented by X2, and then we have now the other constraints. So this is constraint 2, constraint 3, because the available, okay, so the available hours, we had these ones, okay, for assembly. Okay, this is for assembly constraint, and then the other one was for the machine. Okay, so this one was for machine hours. So this is how we are getting down to these constraints. And then from here, solving these ones, we have actually sorted out the solvings here. So the feasible region is coming. So this one is for constraint 3, where we said 20x1, then plus the 65 x2, which was less or equal to 8,000. All right. And then after this, after the graphing is done, we found the corner points of the feasible region is the region where all the shadings come together, which is the one at the bottom here. So the feasible region, the corner points is 0,123.08 and 400,0, and of course the 0,0 at this point. So after using these ones, we found using the objective value function, we have gotten the substituting in this objective function. We have gotten the first one is 0,0, which is 0. Then the other one is giving us 9,231 after substituting. Then the other one is giving us 16,000. So we are trying to maximize this one. So meaning the optimal solution is this one, which is giving us 16,000. So our x1 is 400, x2 is 0, and our z is 16,000. So this one is the final answer. You're looking at this problem. Now, we can even confirm using this pamphlet, from the pamphlet, what was found here. Okay, so from the pamphlet, we can check what was found, the solution of this same problem. So we can confirm here. Okay. You can check out that one using this pamphlet, the solution that was actually found. Okay, so here, this is why they got this linear programming. You can see this is how I formulated my objective function. We're just confirming. Then constraint 1 was this one. Constraint 2 was this one. Constraint 3 was this one. Let's see the graphing. The graphing was, so this was a feasible region. So this confirms that. Okay. And then we are gotten the corner points. Then the other ones, so let's see, the answer should be 16,000. So here, let's see. Therefore, they should produce, okay, C1 400. So this is how this question came. So we have confirmed that the answer should be 16,000. So they should just produce the 400 units, which should actually give us the optimal value. So what is important is just to understand how to draw the graph. We draw the graph using the table of values. So for each constraint, we are supposed to substitute here to get the table of values when graphing. And then we find the feasible region. So these were table of values. So after looking at this, we are supposed to now find the corner points of the feasible region. And the corner points of the feasible region is a region where all the shadings converge, which means they come together. That is the aspect of the feasible region. So from here, we are simply saying that the optimal solution is given by 16,000. I'm sure, have people understood this? Excuse me, have people followed?
Yes, we followed, sir. We followed.
Okay, thanks very much. So just go through, I'm sure the recording will be shared with you by Mr. Njovu, the Collins, so we can end the class for now.
So how are the